Lesson 58 is called the distance problem, but it's not a problem at all because we have math, and math takes what would be problems and turns them into solutions, right? Isn't that nice? So we're talking about problems like Jimmy can drive 60 miles in an hour, so how many miles can he drive in 2 hours, right? And maybe that sounds really simple, right? 60 miles in 1 hour, so make it 2 hours, so we'll just double it, 120 miles. But the key is that we understand the principle, how to solve the problem so we can take it to more complicated ones like this one. So the way we used to solve these, we would take this first sentence and it sounds a lot like a ratio. 60 miles in 1 hour. What are the two rates implied? And don't forget your labels. 60 miles in 1 hour and an hour goes 60 miles. I pick one or the other to use to solve, and if it's asking how many miles, that's a distance, so distance goes on the top. 60 miles over 1 hour, multiplied by the number that we know, 2 hours, cancel out your labels, multiply across, this is of course over 1, so how many miles? 120. So that's how we used to do it. But when we start getting into these more complicated ones, I like to just use the formula they somewhat mention. And that formula, D for distance, is rate times time. I love it because it's an equation you're going to see more in math. You're going to get a lot in science in high school. It's a good one to start getting used to using and gaining mastery of. Distance, rate, time. And a lot of times right now, distance is going to be miles, but it could be kilometers or other things, even feet or inches. Rate, I'm going to use miles an hour usually. MPH for some, just like what we do on the car, right? 60 miles an hour or something like that. And time, lots of times, is going to be hours right now. So those are the labels that'll help tip you off. Let's try using this formula for this next problem. How long would Jimmy travel if he's going 300 miles at that original rate? So we know miles, we know rate, we don't know how long. How long is what? dr or t? That's the t, right? We don't know time. We do know rate. What's the rate? 60 miles over hours. What's the distance? 300 miles. Again, those labels are important to make sure that everything gets canceled out just the way we need it to. So we have time fused to 60 over 1 with this multiplication sign. How do I make this go away on the right side? I multiply by reciprocal, like we did in the previous lessons. And that's going to cancel out 60 and 60. 1 over 1 is 1. Doesn't matter. Hours are canceled. Miles are canceled. Beautiful. We just got t left. That's what we want. But we got to use 1 hour over 60 miles over here too. Keep your neatness. Miles will cancel. We're going to end up with 300 over 60. We could already cancel one of those zeros, so it's 30 over 6. And we still got this hours. So let's simplify all that down here. Let's put it over here. 30 we said over 6, because I took the zeros out. We still had hours left. Equals what? T. Last step, simplify. 30 divided by 6, right? 5 times it fits. So 5 hours is my time, and that's the final answer. How long would it take Jimmy to travel 300 miles at 60 miles an hour? It'll take him 5 hours. So now you can solve those very real-world problems for card tricks. Are we there yet? Well, ask them how long have we been averaging, or how fast have we been averaging for our rate, and how long are we going, and then I'll know. And how far have I gone already, I suppose. Harry could travel 350 miles in 7 hours. All right. Our rate's not so simple anymore. It's not just 1 in the denominator. So it asks us to start with, what's his speed? Speed, we haven't used that word yet today. What has looked like speed that we've learned today? Miles, hours, or miles over hours? Miles per hour, sometimes abbreviated miles per hour like this, is a rate that we also call speed. As long as miles is over hours, we call it speed. So we take the distance and we put it over the time, hours, and that's our speed. Speed is rate with distance on top. Now, is this done? What we learned with rate is we try to make it simplified. So if we can get it reduced, which we can, 350 divided by 7 is going to be 50. And we said miles an hour. You could do MPH if you want, 50 MPH. Now, we got 2 left. With that speed, we're going to take it and apply it. How long would it take him to travel 800 miles? Remember, distance equals rate times time. So 800 is my D. Rate, what was it? 50 miles over hours. Let's write it that way when we use it in a rate or in an equation. Times, we don't know where they're asking us how long. So another one of these problems. 800 equals 500 miles. So we need to use reciprocal over here. 1 hour, 50 miles. Everything cancels, leaving just time. But we did it on the left too. Remember this? 800 over 50, cancel our 0, so it's just 80 over 5. What's our label? This should have been labeled miles. Sorry about that. So we cancel our miles. We got hours left over. So that's our label. And that makes sense for time, right? What's the last step? How long? Do we talk in 85ths of miles, of hours? No. We got to reduce this down, and thankfully it does come out pretty even. 5 goes into 80 16 times. It'll take 16 hours. Nice long car trip, but 80 miles an hour, or what was it? 50 miles an hour to go 800 miles, it's going to take you some time, doesn't it? So it makes sense. At the same speed, so we've still got a rate of 50 miles over 1 hour. How far, so we don't know distance, could he travel in 12 hours? Last one. Can we solve? Cancel our hours across. Now we're just multiplying. We don't have to do anything over here. The D's already by itself. 50 times 12 is 600. 600 miles is our distance, and that makes sense as a label for distance. So I hope that made some sense to you. Keep this video bookmarked. It'll help you solve these distance problems. Why don't you solve A and B for practice? Good luck.